object-oriented programming. So what is meant by object-oriented programming? So it is a depicting the real-time use cases. Like I will have some objects, real-time objects, like employee, customer, manager in the banking environment, all under banking. So in order to develop a software with object-oriented programming, we have programming languages like C++, Java, Python, C Sharp, etc. So whatever we want to achieve, like uh, depicting the real-time use cases, solving the real-time problems, okay, and mapping entities into object-oriented programming, there must be some support. So there will be some requirements and there must be support from the programming languages. So I can use C++ to achieve OOPS and I can use Java to achieve OOPS. Okay, so what is meant by support? Like suppose if I want to declare a class, we all know that class name, so public. So when I write public, when I write private, so I no need to mention anything, whatever I want to achieve, if I have that in mind, programming language provides everything. So what are the, if I declare any variables, these variables are accessible outside. If I declare anything private, these variables are accessible only inside. They are not accessible to outside. So how it is happening? I am just mentioning private, but there is a support from the programming language. The rest it will take care, right? So similarly, in machine learning, deep learning also, we have requirements. What are requirements? I have a digit. And I want to know what is the digit. I have a signature. I want to classify whether this is a genuine or forgery. Like this, I have some requirements. So here I want to identify the digit. Here I want to classify the digit. Some tasks are there. How to achieve those tasks? So I have something in mind. So I need support from the programming. So those frameworks which will help us to achieve, to code what we want to, the tasks we want to achieve are the Tensorflow and Pytorch. They have everything in built in. So we no need to write nothing from scratch. Everything is available. We just have to align. That's it. Same here also. So when you just to write private, okay, so whatever you declare inside the private, these are not accessible outside the class. These are available outside the class. And when you say inherit, class A, okay, public, B, then automatically the public inheritance is happening, right? So it is taken care by the programming language. Same here, okay? So built on top of Python. So TensorFlow and PyTorch are the frameworks which contains the APIs or the functions, ready-made functions, which I can align so that I can achieve these tasks. What are those tasks? Like this. So I want to classify, yes, you can classify. Okay. And if you want to identify, so here you want to classify, yes, you can classify. So to do this, the functionalities, the APIs are available from both, like we have C++, Python, Java, etc. Similarly, for machine learning also, we have TensorFlow and we have PyTorch, we have Cafe, we have Piano. Like this, we have various frameworks available. So by using those frameworks, which provides ready-made built-in APIs, functionalities, I can frame. Okay. So that's why if we want to learn machine learning concepts, there are three things actually. One is, if I want to learn machine learning, there are three types. One is theoretical. I must theoretically understand what is a model, what is a task, what is image processing, what is classification, etc. So theoretically, I need to understand. Next, mathematics. Mathematically, I need to understand. Okay, so mathematically, I need to understand what is happening and how the input is transformed. Okay, so theoretically, they will say, okay, so this is like this. Okay, so this is the image, these are the features we have to extract. But how to extract? What are those features? Which are the operations? Mathematically, I need to understand. Next, I need to implement through code. So if you want to be an expert in ML language, you need to be expert in all the three. So theoretically, you must be strong. What actually happens? Okay, inside, and you have to cross-check hands-on through mathematically, and then through code also you have to code. Okay, fine. Now one question: if you understand mathematically, why you have to cross-check through code also? Because mathematically, if you do, you will get an output. With that, you can cross-check. But still, why you have to go for coding? Can anyone answer this? See, once you do theoretically, once you understand theoretically, you have to cross-check, you have to convince yourself, you have to go deeper. That's why either you can do mathematically, take the values, do step by step, or you can do code. But what I'm telling is you have to follow mathematical and coding also. Once you convince yourself with mathematics, why you have to go for coding? Okay. Is my voice clear? Understanding? No. Okay. Yes. So Pooja, very good. So Pooja Soni is correct. What it means, see, if I want to give multiple input and output combinations, so I want to try various input and output combinations. Okay, I can do mathematically one at a time, two at a time. But if I want to cross check with 200 examples, 300 examples by varying the size of the input, which I cannot do. Okay, so mathematically maybe two, three, or four examples I can take, and I can convince myself that okay, yeah, I understood what is happening in the forward pass, last computation. What is dot product? Yes, but if I want to cross check whether the theory is correct or not, I want to run through some lakhs of inputs. Entire month I want to work on. Then obviously you have to go through code. That's why you have to strong in all the three aspects to claim yourself as an expert in ML. Okay, mastery in any one of these doesn't make you an expert in ML. Okay, so theoretically you have to strong, solve one or two problems mathematically through hand, then do the coding, and then run with multiple examples, then you will get thorough idea. Okay, so to do code, how? We need some support. So yes, you're using C++ also you can do ML, and using Pytorch, say when I say Python, it will be supported by keras or Tensorflow, Pytorch. Okay, now what is the difference between these two? Anyone? So I want to learn ML. So someone chosen C++, someone chosen Python. That means he might have chosen keras or he might have chosen Pytorch. What is the difference? Anyone? What is the difference? Syntax and the library support. Very good. Very good, Pooja Soni. Yes, very good built-in libraries. Yes. Yes. Isaki Rajan. Yes, you are correct. So, see, it all depends upon the support we are getting. How much support we are getting from the programming language. From the C++, we don't have any support. So what you have to do, yes, it is doable. It doesn't mean that without Python we cannot do anything. Yes, by using C++ also I can do it. But what I have to do is I have to write everything from the scratch. So dot product, I have to write a code. Whatever requirement I have to do everything. Whereas if I choose Python, everything is built-in functions are available, libraries are available. I can use them and I can do it faster and efficiently because it is thoroughly tested. I can just use it and do it. That's why. So if we want to mastery over the code, that means through code, if I want to learn, I have to select either keras or Pytorch. Similarly, if I want to get object-oriented programming, grip over object-oriented programming, I have to choose either C++ or Java or Python or C#. So according to our interest, we have to choose, right? Similarly here also. So you have to choose either of these four: TensorFlow, PyTorch, Cafe, Piano. But as of now, because I'm in industry for more than like starting from the deep learning, okay, from 2020, and my PhD started from 2016 in deep learning. So from the past 10 years, so I didn't see much code. Initially, it is there, but either from the industry or from the academic side, there is no much scope for Kaplan and Piano. I think people almost ignored it, forget about that. Only two things ruling is TensorFlow and PyTorch. Okay, academically, people are using PyTorch, and for the industry purpose, mostly people are using TensorFlow, at least in one of the companies which I know. Okay. So, but there is no restriction. Okay. So that's why we try to understand the TensorFlow and PyTorch. So this is what the context which we are setting to know the importance of TensorFlow and PyTorch. So now what we are going to do is starting from the scratch, like from the simple syntax, we'll try to understand and slowly we build the network models and then we'll learn through building. Okay, fine. So yes. So some simple difference. So TensorFlow was developed by Google, whereas PyTorch is by Facebook. See, language back as I said, Python. The Python is in the background. Still some support from C++. Okay. On top of it, we have TensorFlow. Similarly, here also same thing, but the thing is the functionalities. Next, computational model, how it will compute. Okay, so it will compute by building the graphs. Computational graphs will study. Okay, so how to build the graphs, but not much important. Okay, next, see here, production deployment. As I said, for industry, people are using, for production means real-time deployment. That means from industry side, people are using TensorFlow. Whereas for the research, academic purpose, building the models, hit and try, for PhD, etc., people are using PyTorch, but there is no restriction. Okay, so we can say people in industry, few percentage are using PyTorch, majority of students are using TensorFlow. It all depends upon their interest, but PyTorch gives more grip and control to the user, whereas TensorFlow is everything is ready-made. You just have to plug and play, where the user role is very minimum. Okay, but it's okay. You got some idea now. So as I said, let's take some steps involved in image classification, and then we'll see how the PyTorch and TensorFlow plays a major role. Okay, so if you see here anything, so if you see the ML flow, there will be an input. Okay, so that input is fed to few layers, and this input itself is a tensor. Tensor means a three-dimensional set of matrices. And what is a matrix? Two-dimensional. What is an array? One-dimensional. What is a scalar? No dimension. So all we will see. What is a scalar? We'll start from scalar. Slowly we'll try to understand. Okay, dimensions. First we'll try to understand the dimension. Then what are all the basic operations and how we are going to do with TensorFlow and how we are going to do with PyTorch. And then slowly we build towards building the model. So model building from scratch. And in the single neuron, multiple neurons. So slowly, step by step, we'll move. Okay. And everything we have a demo code also. Majorly it is a code based. Okay. Here if you see, it's a code completely. We'll try to learn from the code. Okay. Today's session, morning session and afternoon session, both will try to learn from the coding. Okay. Okay. So let me explain here. So I have a model. Okay, I have a model. So what is that model? Image. I'm taking image concept. So RGB. Okay, so there will be G and blue. Okay, so RGB is what? Uh, this is RGB. Okay, so RGB is, if you combine this, it will be an image. And this image, we call it as a width, height, channel. This is width. This is the height of the image. These are the number of channels. Now, what is the process? This input is what we are going to, this image is what is going to the convolution block. And once the convolution block is done, it will give you the features. That's what you flatten. And then we'll give it to the classifier for classification. And then classifier will give an output. It may be a multi-class output or a single class output. So this is the entire model. This is the ML model. Okay. So this is what happens. So here inside the convolution block, there will be some convolution layers. Maybe one convolution layer or two convolution layer, etc. And then we will have the flatten. Okay. So we will flatten the output. And then we will give it these extracted features. These are the features. And these features, we will give it to the neural network. So neural network will give the probabilities for the class. So this is called as classifier. This part is called as feature extractor. So as I said, in this case, the whoops case, so you have to develop an employee object, the customer object, manager object, and then you have to define the functions. Based on those functions, they will communicate. Similarly, here also, this is the workflow. Okay, so here you have an image, and image is used those. If I want to classify the image, recognize the image, or if I want to classify the signature as a real or a forgery, so these images I feed it to the convolution block, where it will perform a convolution layer 1, convolution layer 2, and there will be a max pooling or whatever it will be, normalization or max pooling, something will be there. Like this, it will keep on repeating, and the final will be the flattened features. This is for classification. So here, see, here, that's what here we need support from TensorFlow and Pytorch. See, this is a requirement. So how to represent an image? There should be a support in Pytorch or TensorFlow. That's what, see, whatever our aim is to learn about TensorFlow and Pytorch, but with respect to the model, no need to go to unnecessary things because the time is limited. Okay. Similarly here also, what is the role? How I can do the convolution? Okay, how I can define the normalization. Okay, and when it comes to classifier also, so how I can feed in the data to the neural network, and if there is a single neuron which we call as a perceptron, how to feed in the data, and what are all the operations it will be performed, and how the weights. Okay, so how the input is transformed and passed to the next set of layers. So in this workflow, how I can use the Pytorch and TensorFlow is what we are going to study. Okay, so before going to this, first we'll try to understand the basics. Okay, so this is what I explained here. So text image classification. So input. So I have to give the input. So the input is 28 cos 28 pixel. Next, see layers. That's where the processing will happen. So these are all the data. So you have to represent this is a pixel. Okay, so this is a pixel. Each number is these are the pixel values. So 28 into 28 into 3 is the number of pixels I have. There is no parameter, Sony. Actually, once you join the industry, okay, nothing is in your hands. Earlier projects, if they are working on TensorFlow, you have to work on TensorFlow. And if earlier projects are working on the Pytorch, you have to use the Pytorch. But as I said, whichever is convenient to you, which see, I like TensorFlow because initially it helped me to quickly learn the ML and DL to implement. So few people will like PyTorch. So they want to code everything. They have to get more control over the computations. So they prefer PyTorch. Okay. So it all depends. There is no parameter. See, yes. So if you know both, it will be very helpful. If you are master in both, it will be helpful, but not mandatory. Either TensorFlow or PyTorch. If you are master in one framework, it's okay. If you know both at expert level, it is also welcome. It's all independent here. Depends upon the person. But thoroughly, you learn at least one so that you can develop models and do the research work. Okay. So there is no criteria. And if you go to industry also, you are not supposed to do whichever way you want. Whatever every company projects majorly stick to uh, PyTorch or uh, TensorFlow. So you have to follow the same trend. Okay, fine. So yeah, so here, so this is what the tensor processing. So these are the numbers and how you are going to process. So these numbers start from a simple scalar. This is a scalar. This is a scalar. And in this row, this is an array. Array means first row. This is second row, which I can call it as a array or a vector. And set of all these things, the red, complete red, I can call it as a matrix. This is a matrix. This is a vector, or I can say array 1D. This is 2D. This is 1D. And this is, I call it as a scalar with 0 dimension. It doesn't have any dimension. It's a single value. Okay. The row is called as a vector or array. And then 2D is a matrix. Collection of matrices, all these three, I call it as a tensor. Okay. So I need to represent the data. I need to process the data. Why I need to process? Every operation, convolution, or here also in the neural network also, you have to take the input and you have to multiply through the weight, you have to get the output. So it all depends upon the number processing, information processing. Okay. So now let's go. Okay. So see here. So see here. So this is where TensorFlow or PyTorch come in. So they help you to create layers of math operations. See, ultimately, inside machine learning and deep learning, what happens is a serial processing of the data. You may call convolution, I may call it as a fully connected network. But what is happening? The tensor, these three numbers are going through one set of operation, another set of operation, another set of operation, another set of operation, and that's what we flatten. And that and again goes to some set of mathematical operations. Finally, we are giving the output. It's dealing with the numbers. Okay. You may call it as a feature. I may call it as a image input, etc. Okay, so each layer transforms the image or extract the features, and then it will try to learn the edges. Incrementally it will learn, like simple linear features, horizontal features, vertical features, diagonal features. Okay, and then keep on combining those simple features to form a compound features. Okay, so that's all happens in a neural network. That's what we are going to take, and then we'll apply some activation function. We have to apply. So why we have to apply an activation function? To project the values from one space to another space, a higher dimensional space. So at each layer, we apply a decision function called as activation function. What it says, these features are helpful and these features are not helpful, like ReLU, etc. So what ReLU will do, if you don't understand, no problem. So what ReLU will do, ReLU of X equal to max of, so what it will do, max of 0, comma X. That means if you give any negative numbers, it will give 0. That means we are nullifying all the negative features, negative values. The features, the inputs, okay, which are 0 and above is what we are considering. So that is called activation. What matters, what to ignore is what we are going to uh, uh, decide with the activation function. That means another way we can say activation function is it will project the values. See, if I say ReLU of -5, ReLU, suppose -5, ReLU of -5, what is the output? 0, comma -5. What is the maximum value? 0. So the output is 0. That's what I'm projecting from one space to another space. So this space is more representative. It will give more representative features. The features are more qualitative. That's why the activation function plays a major role. The problems which we are unable to solve in a lower dimension, if we use a ReLU, I can project you a different space, and these features, this feature vector is more representative. Okay, this feature vector is more representative compared to this feature. This will help us to learn more about an object. Okay. Yes, yes. So finally, what we will do after performing some serious convolution or fully connected operations in convolution or dot product, then activation, then next convolution or dot product, next activation. Finally, once we done, we apply the softmax to learn about the probability, the features, how probable the features represent in the class 1, class 2, class 3, etc. Okay, very good, Karthik. Yeah, so that is what happens. So why I'm telling all these things, at everywhere I need support. This is what I'm going to, these are the steps I need to perform. For that, I need a support from the language framework and output. So this is what the output it will give. Suppose this is the class 1 probability, class 1 probability, class 2 probability, class 3 probability, class 4 probability. So which one is higher? This one is higher. So the input 0, 1, 2. So the input is 2 or something like that, which represents this one. Okay, like this. And then what happens in, so no model is perfect at a single stretch. So it has to learn the weights. So we have to represent loss function. We have to compute the loss function, and then we have to back propagate. So first is forward propagation. Next we compute the loss, and then we perform the back propagation. So this is how my model learn the weights and will converge. So when I want to develop any task, I need a support like this. How I can represent the input, how I can process my data, how I can apply any activation, and finally prediction, and how I can make my model to learn. So these are the 5 critical steps I need in any problem. So I need a support. Okay. So first, how it going to help us? Okay, we are going to study now. So whatever we study, we want to map it to ML perspective. Okay. So like this, so we need input. So there must be, you don't need to worry. We'll see. See, input. What happens? You are going to give the input to the model, a set of numbers. So see here. So we need TensorFlow dot keras dot preprocessing dot image. some support. You don't need to worry about this. See here, torch.utils.data loader. I need to load, I must able to load the data. I must able to pre-process the image. Next, tensor conversion. So I need to perform with tensor, three channel. See here, convert to tensor, tf.constant, torch.tensor. Next, I want to define a model. Okay, I want to define a model. So how I can define a model? See here, either sequential model or a one is a sequential. Okay, another one is you can customize. Okay, you can write on your own. There is no order. Similarly here also, if you want to develop a sequential model or a NN dot module. So whatever requirement you need, I have a support in terms of the functions, ready-made functions. Next, forward pass. I want to do the forward pass. So model dot predict will do that, or model of X will do that. Keyword. See here, forward. When I say forward, input goes through all the layers. Similarly, loss calculation. See here, I want to compute the loss. See here, I want to compute the loss. Learning from mistakes, I need a loss function and backpropagation. So how I can define the loss? Categorical. See, Tensorflow.keras.losses. Here also same thing. Torch.neural network.cross entropy loss. So when I say fit, the actual training is happening. Here, the loss is forwarded. Means the loss is backward propagated. So whatever the steps, these steps are generic. See, these steps are language independent. Whichever language you take, this you have to implement these steps. Which language will provide easy steps to support these operations? We have to opt those frameworks. Okay, so it's your wish, like TensorFlow or Pytorch, equally good. Okay, so like this. So I need to represent an input. I have pre-processing.image. Torch, we have data sets. Similarly, tensor conversion, convert to tensor, torch.tensor, model, sequential model. Here, NN.sequential. I need to learn the weights, model.predict, forward pass. Okay, and then there will be a difference. I need to compute the loss between my model prediction and the loss function, categorical cross entropy. I need to backpropagate my loss, model.fit or backward. So like this, I have some support. So like this, okay, optimizer. Okay, how I can evaluate my model, model.evaluate, model.evolve. Once my model got trained, I have to save my model, model.save, or tf.keras.models.load model. Then if I want to load, if I want to save, model.save. Then if I want to load, tensorflow.keras.models.load. So everything, the functions, everything, these functions are available. If I want to load back, torch.load. If I want to save the model in PyTorch, torch.save. So like this, we have support. Then we have to use these functions and we have to follow for each step. There are functions from PyTorch and TensorFlow. We have to use them and we have to complete the task. So these are the support. Without this support also we can do. So inside what is there? There will be some function. Nothing is magic. When you say model.predict, in the background, there will be some function defined, like stdio.h, conio.h, math.h. How you are able to perform when you say conio.h or when you say math.h, it is able to perform the math operation. Why? Because somewhere they define the code. Similarly here also. If you say model of x, somewhere the code is defined. Okay, so you can use the code easily. And if you are expert, you can use your own function. You can write your own functions in C++ and you can call them and you can implement them in C++ also. Okay. That's why we have to study PyTorch and TensorFlow. Hope is this clear? The foundation is clear. The setup is clear. What actually we need to study and why we need to study. Hope it will be clear, right? Anyone? Is it clear? Okay, thank you. Thank you. Okay, so now what we are going to do is first some basic data representation. Yes, yes, Aditya, we'll see. I will explain, no issues. Okay, so first, what slowly we'll develop step by step. Okay, so first we'll look into some data, then slowly simple networks. Okay, so all those things we are going to study. Okay, okay, fine. Let me share, and then we'll go for the details. Okay, so see here. So first main thing is the number. Okay, so if you see, this is a, see here, this is a zero dimension. Okay, so just any number, 5, 3.0, any input, the numerical input which we are going to give, we are calling it as a number. Feature, single number. Shape is nothing because zero dimension. A scalar, a single scalar is a zero dimension. Next, vector. What's a vector? An array. See here, an array, which is a 1D. I can call this as a vector or array. Next, see here, shape. Three elements, three, comma, one dimension. Only this one dimension. Next, two dimensional. Two rows, three columns, like this. This is one row, this is another row. This is one vector, this is another vector. Each vector is 1D. What is 2D? 2D means 1D element, comma, 1D element. So we have 2Ds. What is 1D? One dimensional, one row. Next, tensor. Tensor is a collection of matrices. So this 2D, I'm calling this as a matrix. Okay. So matrix also like this, right? So matrix, it's a collection of rows, arrays, vectors. And now, if I want to represent multiple matrices, see here, this is one row, this is another row. Like this, I have one more, one row, another row. See this, suppose, see, this is this, like this. So this is this, and this bracket is this. Inside that, one image, comma, this comma is comma, another image. What is this? This is a matrix. What is this? This is a matrix. Now the same thing if we see, what is a matrix? Matrix means, see here, matrix means set of rows and columns. So see here, 1, comma 2 is one row, comma 3, comma 4 is another row. So this is okay, one image, this one. Similarly, 1, comma, again, one more matrix. Okay, so if you see shape is 2. This 2 means 1, 2. Inside that, if you go to one thing, if you take 1, it will be represented like this. Again, 1, 2. So this is 2. If you go inside, if you take anything, 2 columns. Okay, 2 columns. So that is 2. So number of columns, number of rows, like that, how many I have? I have 2. 2 rows, row 1, row 2. This is row 1, row 2. Each row, 2 columns. Okay, so that is. So tensor 2, 2, 2, 2 rows, 3 columns. Okay, see, row 1, row 2, 3 columns. Vector is a one dimension. 3 elements are there. 3 elements. No dimension. Okay. Now let's go and see. Let's go and see the code so that we can understand. Okay. So see TensorFlow. How to define? Same thing. It's TensorFlow Pytorch. It is a constant. So first you have to import TensorFlow as a TF. Same. If rather than using TensorFlow every time. One second. Garima? Tell me, Garima. No, Garima. No. I think Abdul knows all these things, but he's absent. And check with this guy, Vijay. Vijay, he knows. Yeah, yes. Okay, sorry. So okay, see, TF dot constant. Same. See, everything remains same. So import TensorFlow as TF. So whatever I want to, rather than repeating the TensorFlow multiple times, just TF dot constant. What is this constant? This is a scalar constant. You should not change. Okay, next. Same thing. Scalar, I'm just printing scalar and what is the shape, dot shape. Similarly here also, I just import a torch. So here also, I'm just importing the torch and the torch dot. This is a tensor. So tensor of 5. Okay. So torch scalar. This. If I run this, so this is also empty shape. This is also empty shape. And the value is 5. And see, TensorFlow is printing more information like it is an integer number, but Torch is not printing, but not a problem. Okay, that is how this one. So why? Okay, that is one case. Next, second vector, 2 dimension, 1 dimension. This is not a dimension. That's why we didn't get any output. Now see, I represent this as a 1D array, 5, 10, 15. Same thing. This is also constant. Same here also. Torch dot tensor, same thing. Now, and let's try to print it. So if I print it, it says that 3 elements are there. It's a 1D dimension, integer type, integer this one. Shape is 3. Same here also. Both are same. But see, here it is telling as a constant. Here it is telling as a TensorFlow. Okay. Next, 2 dimension. See here, constant. This is row 1. This is row 2. And this is 3 columns. TF dot constant. So you are specifying 3F dot, you can specify anything. Here also, dot tensor, you can specify anything. Then you are just printing the matrix and shape. See here. So when I declare a tensor, it is like this. So constant, whatever you declare, it is like this. This complete thing is a matrix. 2 rows, and 3 columns. This is also same thing. 2 rows, 3 columns. Next, tensor. See here, constant like this. See here, this is only one thing, one matrix. Now like this, see, this is one row, this is another row. These 2 rows are combined to form one matrix. Like this, another matrix. This is entire thing is one entity. Same here also, same constant tensor. Okay, when we run it. So it is like this, 1, 2, 3, 4. 1, 2 is one row, 3, 4 is another row. If you combine these two, this will be one matrix. This is another matrix. You combine together, it forms a tensor. So 2, this 2 means 1, 2, whole thing. This 2 means 2 rows, 1 row, 2 rows. This 2 means 2 columns. Okay. Yes, why comma after 3? Where here? He is asking about the, see, 3. This says that this contains 3 elements. This is syntax, okay? So 3 elements, 1, 2, 3, and it is a 1 dimension. Okay, 1 dimension, 3 elements. Comma, 0, nothing. There is no dimension. Comma. See here, we are using this comma, right? Is shape while declaring shape, comma. But here there is no dimension. 3 elements are there in the one array. One array, 3 elements. Okay. Fine. So these are the various things, data. Now tell me, so this is what the input. Okay, this is what an input we are passing. Various types of input. See, ultimately this is an input. It's not always an image. So you can pass some set of one-dimensional elements to the neural network. So now here we will focus on the neural network. So one input you pass to the uh, neural network, or you can pass only the scalar to the neural network. Like this, anything. It depends upon the problem you are handling. Okay. Suppose if you are performing any, if I have a data set, I can show you. I don't have. Okay. So anything, if you have such data types, Excel sheet data sets, all Excel sheet data sets are, see, like this. Okay. Somewhere, customer transaction. Still like this. You may pass a single value, or for each customer, you may pass like this at a time. You may pass single value. Suppose for a customer, what is the name? So you may pass a single value, scalar, or you may pass each customer data together. So it will become a 1D. Or you can pass all customer data together. It becomes a 2D. So scalar, vector, matrix. Like this is for India, and maybe for another country, another set of customers. Then you can add. So like this. Okay. So this is one country. This is for another country, another country. So this is for another country. Like this, you are adding. Now tell me, what is the shape of this? Can anyone tell me what is the shape of this? Ignoring the features. Ignoring the features. Okay. Yes. Ignoring the features. Ignoring the features. Features mean first row. First row you ignore. Then tell me. 344. Who are all pinged 344? They are correct. Why? Why? Because first, like this is one unit. Entire thing is one unit. Like this, how many are there? 1, 2, 3. So I have three matrices. Then if you go to one matrix, how many rows are there? How many rows are there? How many columns are there? How many rows are there? 1, 2, 3, 4. 4 rows. That is here. How many columns are there? 1, 2, 3, 4. If you consider this, if I consider this, then what will be the shape? If I consider this also, what will be the shape? It will be 3, 4, 5. Correct? If I consider the above feature names also, header also, then what is the case? 345 or 354? Very good. It is number of units, fundamental units, 1, 2, 3. If you go to each unit, how many rows are there? 1, 2, 3, 4, 5. So 5 rows are there. Then columns, 1, 2, 3, 4. This is the shape. Okay, fine. Then, so we studied about scalar, we studied about vector, we studied about matrix, we studied about tensor. Now, what kind of operations we can do? See, ultimately, as I said, the input is getting transformed by performing some set of operations. Correct? So when input is getting transformed, what we are doing? We are performing some mathematical operations. What is mathematical operations? It's like this. A scalar is multiplied with scalar. added with scalar, multiplied with scalars. Scalar into vector, or scalar plus vector, vector into vector, matrix into matrix, matrix plus matrix. These are the things you are doing. Now tell me, in convolution. So you may know convolution, but can you tell me, and now can you tell me which operation is majorly used either in the convolution or in the neural network? Among these, which operation is most important? Very good, very good, very good. Matrix into vector. See, everything is important. Which one is more important? At some point of time, if you go deeper into the network, it may be scalar into matrix, scalar into scale. All operations will happen. But majorly, it is what it is. Matrix into matrix. Why? Why? Because convolution operation. Okay. So what is a convolution operation? Or dot product also. Convolution or a dot product. Let me take the slide. I will just take the slide so that I can easily explain to you. One minute, let me take the slide. Yeah, I downloaded. I'll just show you. Okay, I will show you. Pooja Sony, yes, very good. W transpose into X plus V and convolution shifting and build. Very good. Very good. Okay, so I'll just show you those because once you visualize what is convolution, rather explaining the theory, uh, if I show you, you can appreciate, and then we can go through coding also, like how to do that. Okay. Okay, so I got it. Let me share, and then I will show you convolution, and then same we will learn here itself. Okay, here also we'll apply. We'll learn those. Okay. Yeah. So let me go to convolution. Neural network both are same, more or less the same operation will be performed. Okay, this is not part of the course, but convolution I want to show you visualize. Okay. So this is what she said. Weight transpose into input and then applying the activation. So this is how, see, at a time we are sending the inputs and then we have to multiply with the weights. So this is one vector. This is another vector, vector to vector multiplication. That will give you the output. That output we are going to multiply here. Then it becomes a same thing, one input, one output, scalar multiplication. Got it? First, these two, this is the input. Okay, so first what we are going to do, this is the input. Dot product with the corresponding weights. And the output, the resultant value will be here, 6, suppose. And 6 we are going to multiply with this. So scalar into scalar. Next, these two, same dot product between these two. This is the input and this is the weights. And these two are going to multiply. Say you may get 7 and that you are going to apply here, scalar. And then you will finally, you will come here. Then you will apply the non-linearity. And then you will get the output. Okay. So if you see the same convolution also same thing. Yes. So this is the image. Assume that as of now we have only one channel image. So this is the width of the image, which is equal to 6 pixels and height is equal to 6 pixels. So when I multiply here, these are the filters. So what is happening in case of see here? So this part of the image. So what is this part of the image? It is a matrix. What is the size of this matrix? 3 into 3. And what is this filter? This filter is also a matrix, which is 3 into 3. So what is convolution or a dot product? So see here, you are multiplying each element, one with one, part of the patch of the image, 0 with -1, 0 with -1, like that. You are performing corresponding elements and then you are adding. So matrix into matrix, dot product. So that is how you are performing matrix into matrix. By moving the filter, you will get this matrix. So a matrix, subpart of the matrix you will take, multiply with the matrix, and then you will move from left to right, top to bottom, you will get a resultant matrix. And then you have one more filter. Okay, you have one more filter, that is filter 2. Same, that filter 2 also you will perform. Then you will get a matrix. So now this became, see here, this is what you are passing it to the next layer. The resultant of convolution of two filters is this. So this is 4, this is 4, 1, 2, 3, 4. Like this, I have 1 and 2, 2. So this is 4 cross width into height into channel. So this is what you are passing. So this is a tensor. So everything is a data representation like tensor, matrix. That is what you are going to send it to the next layer. Okay, that is what convolution. It is enough to just to go ahead with our regular part. So let me close this. Okay, so now like this. So matrix into matrix. Okay, scalar into scalar. Simple addition of two numbers. So constant, this is a constant, tensor, torch dot tensor, and then these two you are adding like this, scalar plus scalar. Okay, next scalar plus vector. How you will do a scalar plus vector? Scalar is 2, a vector is like this, 1, 2, 3. Now how you will do this scalar plus vector? Tell me the resultant. Same thing, you have to add same element. So which is equal to 3, 4, 5. Same product also same. Same matrix also same. Plus this is a vector. The condition is it must be of same size. Okay, so if this is 1, 2, 3, okay, and if this is 4, 5, 6, you will add corresponding elements. So 1 plus 4, 2 plus 5, 3 plus 6. Okay, like this. So now same we can do it here also through code. I will explain. So see here, basic scalars. So we understood scalars, etc. Okay, and then fundamental operations. So 5, 3, I'm just adding here. Same tensor, I'm just creating torch.tensor. I added. So I got C. TensorFlow answer is 8. This is shape because this 8 is a scalar. Scalar plus scalar is also a scalar with 0 dimension, integer 32. This is tensor. Same here. This is a scalar and scalar plus this is a vector. Scalar, vector. I'm just adding. Similarly here also. Same. Scalar plus same here. See, scalar, vector. Okay. Next see. This is a scalar. I want to add this to matrix. Same here also. And then when I run, if you see here, okay, so same 2 plus 1, 3, 4, 5, 3, 4, 5. So 3 dash, what is this indicates? 1D vector with 3 elements, and each element type is integer. Okay, next when it comes to tensor, so first 1, 2, 3, 4, it will be like this 1, 2, 3, 4. When you add 2 to all, it becomes 3, 4, 5, 6. Now it becomes one row and the row 2 comma. Same here also. 3, 4, 5, 6, 3, 4, 5, 6. So fundamentally, either you use TensorFlow or you use Pytorch, the result is same. But the way you have to write, that may be different. That you have to keep it in mind, else it remains same. Okay. Next, see here, vector. This is 1, 2, 3 is one vector, another vector. Same Pytorch also. Vector plus vector. Same. One corresponding elements. 1 plus 10, 2 plus 20, 3 plus 30. That's it. Now, see here. This is one vector. This is a matrix. Yes, you can do that. Now tell me the output in case of this. What is output? Yeah, Abdul, convolution is one of the operation, okay, used to extract the features. Okay, so slowly, once we go through this summer school, you will thoroughly understand convolution also. Okay, so you no need to worry. As of now, you assume that convolution is applying a part of the matrix over the image. Image is also a matrix, but a bigger matrix. Filter is one smaller matrix. This smaller matrix, you keep on moving over the image and you'll perform the dot product. That is used to extract the features. Okay, so now you see what happened. So what I'm doing, I'm adding. When I add, what happens? Corresponding elements 1 to 10, 11, 40 plus 1, 41. Same thing, first position. So it will be like this. It will be like this. Same thing. Okay. So because this is one matrix, right? So this you have to do. And same thing comes to here also. Because this is 2. It is like this. Okay. It is like this. It is like this. And this is only one vector. So same elements, you have to add it here. And same elements, we have to add it here. So corresponding elements now. So 10 plus 1, 20 plus 2, 30 plus 3, same 40 plus 1, 50 plus 2, 60 plus 3. Okay, vector addition, same here. Just you can add p plus m, v plus m is same. See, the operation is also more or less same. The only thing is the way you represent. Okay. Fine. So more or less that what two matrices also you can add like this, same operation. Okay. Now see, different thing. Multiplication. Now tell me the output. Tell me the output. So if you see how they did the multiplication. So they did the multiplication. They use see TensorFlow dot overall is TensorFlow. See how it will be like this. Tensor same like a C language. Suppose if I have a C language or a C++ language, the whole thing is C++. Whole thing is C++. Inside we have various libraries. One library for mathematics, one library for uh, calculus, one library for geometry, like this. So now whichever function you want, so C++ dot, if you want to use any math function, so you have to go to math. If you want to use any other geometric method, predefined method, geometry. Like that, we have to go inside. Same here also, TensorFlow also. So TensorFlow is also having linear algebra. So whatever operations you want to, you are going to perform in linear algebra for every function, matrix addition, matrix subtraction, matrix inversion, transpose of the matrix, everything, the functions are there. So which operation you want to perform between two matrices or the matrix vector or vector vector, you have to choose corresponding method. That's it. So you no need to write which operation you need to perform, where it is available. You can just Google it, it will give you. So you don't have to worry about that. But you must know how to do that. Like what I need to pass. Okay. So TensorFlow, in that there is a linear algebra functions. In that, I want a function called as mat vector. So what is a mat vector? Between mat and vector. So you are passing a matrix and vector. Then that's where we are performing the linear dot product multiplication. Okay. So if you see here, so mat vector. So what is a matrix? What is a matrix here? Matrix means two dimension. This is a matrix. Vector means this. Okay. So now it will be like this. So I have a matrix 10, 20. This is a vector. Okay. And what about this? Matrices. Okay. Okay. So this one. 1, 1, 2. Okay. So what will happen? See, 1 into 10 plus 2 into 20. Okay. Same. Position wise. Okay. So here, what is that? 1, 2, 3, 4. Okay. So 1, 2, 3, 4. Same what I did. Part of the filter, part of the image. What we did? So this is the entire image. Just now we have seen the convolution operation. Part of the full image. Inside I have taken a patch. Patch means subset. This is my filter. This is also a vector. This is a vector. And then that's it. 10 into 1 plus 20 into 2, 40. Dot product addition means 50. Same, 10 into 3, 30 plus 80, 110. So we got 50, comma, 110. This is the dot product. Corresponding elements wise multiplication, not a matrix, not a matrix multiplication, dot product, element wise. 10 into this plus 20 into this. Same this matrix. 10 into this, 20 into this. And you have to add element wise multiplication. Okay, same here also. So we got this. Okay, next, see, now it become matrix multiplication. 1, 2, 3, 4, 5, 6, 7, 8. Same like this. Now it is a matrix multiplication. 1, 2, like this. Okay, 1, 2, 3, 4. 1, 2, 3, 4. You have to multiply with this one. What is this? 5, 6, 7, 8. So 5, 6, 7, 8. You have to multiply. That's it. So 1 into 5, same thing. 1 into 5 plus 2 into 7. So this number of columns must be equal to number of rows. So 1 into 5 plus 2 into 7. Next, 1 into 6 plus 2 into 8. Same thing here. Same thing. Okay. So either this one. Okay. Mat multiplication. These are the values. Okay. Like that, you can perform case of tensor also. So those are the various operations. Vector, vector, matrix, vector. We have seen all these things, 50, all those things. Okay. So like this, matrix to vector, matrix multiplication between two matrices, transpose, determinant, inverse, norm, eigen, everything is available in the, as I said, in this that library, TensorFlow library, wherever that we are using the TF dot, linear algebra dot, all these are available. So which operation you want to perform? you can perform. Next, so all these things is over. Now, model building. So once we understood the fundamental aspect, the data representation and the mathematical aspect, that's it. The entire model neural network is, first you have to understand what constitutes your data and which operation you are performing. That's it. Okay, so if I say convolution, some modification. If I said neural network, some modification. But ultimately, what is happening? The bigger part of the image, on bigger part of the image, there will be a matrix called as a filter matrix. So which you use to take the dot product, then take the dot product, take the dot product. Like this, you keep on moving from left to right and right to down. You will take the feature extraction. When you say that it's a feature extraction, but ultimately it is happening the dot product between two matrices. That is what the Pytorch is supporting. Okay, so till here it's fine, right? Any doubts? So till here it is fine, right? Any doubts? Mukesh, class lo no Mukesh, chasa Mukesh. Any doubts? But any doubts you can ask. Fine, very good. So, yeah, see, machine learning, deep learning is nothing. There will be numbers from data point of view. There will be numbers from the filters point of view. So you apply this filter on the input data to extract the features. Based upon the features, you will classify. That's it. We can use math, directly, right? Yes, yes, yes. Anything you can apply, no problem. Okay. Now slowly, I'm coming to the model part, model building. So what is meant by model building? So I will take a neural network. So convolution, I think some other professor will teach. So I will take either, we can take this also as a model. So slowly we'll try to build simple model and then we'll try to understand. Now you see here, there is one neuron, only one neuron. See here, one neuron. And then, so what I will do, one input I will give to the neuron. And what neuron will give you the output. Next, I will increment this input to 2 inputs. Next to 3 inputs. Okay, next, what I will do, I will build one neuron, second, 2 neurons. This is what the neural network is. This is what my one of the layer. And then say what I will do, I will take one input, incrementally, we'll try to learn. Now, 1 input, 2 input, 3 input, n. Same thing, what I will do, I will create the 3 neurons. 3 neurons. Anything you can create. So I will create 3 neurons, maybe it post session, and then we'll try to take this input, one input incrementally I will do, so that you can try to understand. Next, I will do one more layer. With that, we can thoroughly understand the neural. Is this clear? This is what we are going to learn in the model building. That means we will also learn how we can use Tensorflow and Pytorch. How we form filters. Very good. See, filter is what the model will learn. The numbers in the filters is what the model will learn. That is called machine learning and deep learning. So you have to learn. I have an input image. Okay. So let me show you. The convolution. I don't know the correct term. Okay, see, see here. This is what we have seen, right? This is the filter or a kernel. This is the input image. So input image, I am extracting the features. What kind of features? These kind of features. That means whether a diagonal element is present or not. Like this cross symbol is present or not. Wherever we have one, that one is what that one indicates the presence of a feature. So whether we have this kind of a feature or not is what we are going to work. Okay, let me explain. He asked one good question. Let me take 1 minute. Okay, let me open that. Let me open that. Okay, see here, this is the image. Yeah, this is one filter. So if you see this filter, this filter is having ones in this direction. Wherever ones are present, that means this is the pattern I am looking. Present in this image or not? Yes, it is present. Where it is present? Here it is present. Here it is present. But how I will find out? Let's see. So what I will do, I will do the dot product between this patch of the image, this filter. What is the resultant? I got 3. Next, I will move one step. I got -1. Okay. See, next I got -1. Next one step, next one step, next one step, next one step down. Next same I will repeat. Dot product. This is what I got. Now, this is the activation map. What is this resultant? This is called convolution. So moving this filter over the image step by step is called as a convolution. And these are the resultant of dot product values. Higher value indicates feature closer. That means that patch will contain closer to the image. Negative says that reversal means far away. This part, which is this part? This part came from when I multiply the filter with this part of the image. This came when I do this part. This part came when I do this part. So this part, see, there is no matching. This part and this part. So negative says that this patch of the image is far from the what I'm searching for. Now, wherever there is a positive, see here there is a patch. And now here also patch. When we got this number, when we multiply this part of the image with this patch. Now, the question is how I will come to know. The model has to learn these numbers. I will apply n number of filters to extract the features. And based upon those features, I will try to classify. If my classification go wrong means the features I extracted is wrong. The features extract is wrong means the filters is wrong. So these numbers will keep on changing, will keep on converge, transforming at one point of time, it will converge. Until these filters converge, my model is giving wrong out. So these values are learned through backpropagation. That is called training. Hope is it clear? The one who asked the question. Okay. Now, okay. So that is what convolution and learning about the features. So now let's come to model building. So what I want to do is I want to build from scratch. So I want to, so what I'm doing, see here. So one input, one weight, no bias, linear activation. So I have only a single neuron. What a neuron will do, I will give an input. What is the input? So this is the input, X. Always input is multiplied with the weight. So here there will be weight. Some operation, neuron will always perform the operation. What is the fundamental operation? Weight into input. The input is multiplied with the weight. This is the fundamental operation in machine learning and deep learning. The feature learning is every input is associated with the weight, which indicates that how much proportion of input I need to pass. Suppose input is 100, my weight is 0.1. That means I'm considering only 10% of this input. The importance I need to give is only 10%. So you have to learn that weight. That is also learned through backpropagation. Okay. So what is the fundamental operation? X into W. It will perform inside here, X into W or W into X, whatever it may be, that it will pass. That is the output. This is the output. So y equal to Wx is the fundamental value operation. If you have more numbers, it will become W transpose into, then it becomes a vector W transpose into X. Okay. So now see, if I pass 8.5 as an input, if my weight is 0.1, 0.85 is my output. That is what a single neuron, also called as perceptron, a simple neuron, will behave like this. Okay. Next, I will show you through the code also. Now I have two inputs. What are the two inputs? Two inputs means single neuron. Now my inputs are two. So one is 2, another is 3. So 2 is connected to this, 3 is connected to this neuron. Every connection must have a weight. There is no input without weight. So weight, must weight. So what are those weights? 0.4. So here I have 0.4, here I have 0.6. What is the fundamental operation of this neuron will do? Dot product. What is dot product? Input into weight plus input into weight plus input into weight plus input into weight. So how many inputs you may have? So those many corresponding weights will be there. These are all inputs. These are all weights, all connecting to one neuron, all connecting to one neuron. So which is equal to weight transpose into input. That is equal to, you have to multiply 2 into 0.4 plus 3 into 0.6, which is equal to 2.6. If I have three inputs, so I have three inputs, accordingly, I must need three weights, then corresponding into, then you have to add all. See, you have to add and then you have to multiply. This is called as dot product. Dot product means corresponding elements you have to multiply plus you have to add. So this is corresponding input into weight, input into weight, input into weight. That product you have to add. That is called as dot product. That is a fundamental unit of operation in the neural network. Okay. So now you see how to represent the same in the Pytorch. So how I can represent in Pytorch. So let's go here, model building. So I have, so see here. Now, one important thing is that when I say the input, now input is there, weight is there, which is constant, which is a variable. Both are variables or both are constant. Tell me. Which one is a constant? Which one can change? Yes, we will come. We will come. I will explain. No issues. Input constant, weight variable. Very good. Very good. Weight is variable. It's very good. So you all know this. So why you are telling weight is a variable? So why you are telling weight is variable? Why not weight is a constant? Why not weight is constant? Why everyone is telling weight is variable? Very good. Very good. Very good. Okay. Nice. Vinny, push, everyone knows. See, why weight is a variable means I don't know the exact value, but I know the exact input. I know my inputs. I don't know the corresponding weight. I have to learn that. To learn that, I will start from some random value. Suppose my weight is 0.16, I don't know, I will start some random value, then slowly through back propagation by using the formula. Or if you don't know the formula, so if you don't understand the formula, new weight equal to my old weight minus the learning rate into the gradient of that particular weight into the loss function. Don't worry. That means iteratively, I keep on updating my new weight. So I will start from some value, then I keep on updating, and at some point of time I will reach the 0.6. So weights is keep on changing, but for a fixed problem, input I won't change. Okay. So that's why here if you see the constant, the input is constant. X is input to the neuron. TF dot constant means its value will not change. This is like giving a neuron a signal of strength 8.5. But when it comes to weight, we are calling it as a variable. So W is the weight of the input. The variable means it can change during the training, a trainable parameter. During training, it will change. Okay, next, I am performing the multiplication, input into weight. Because it is two numbers, I can just multiply, and that will give you the output. I'm converting it to NumPy array. Okay, rather than just displaying a number, I'm just uh, converting it an array. Okay. See, this is the difference. Okay, this is a tensor. Okay, so tf dot numpy and y. This is a tensor. This is a numpy array. Okay, this is tensor. This y is a tensor. This what you just converted into numpy. Same thing here also. You are calling this as a tensor 8.5 fixed value. In tensor, it's a fixed value. Next, parameter. So here you are calling as a variable. The same thing here you are calling it as a parameter. So torch dot, because I'm dealing with neural network. So neural network dot parameter. What is it parameter? It's a torch tensor 0.1. So 8.5 is one. When you multiply, see what we are doing here, just multiplying. That's it. The value you got, and you're just using detach dot numpy. Detach removes the tensor from the computation graph. You're removing the tensor and you're taking that value, you're just displaying. You don't worry about that. So this is the thing. Tensor means fixed value, parameter variable, and then how you'll multiply, simple just multiply. But here you have to use multiply. That's what the difference, x comma w. Here you can just multiply. Like this, you can. Okay. Next, two things to see here. Okay. So this one, see here, TensorFlow, two inputs. It's a vector or array. Variable, my weights, corresponding weights are also there. I am using tensor dot product. So x comma w, axis equal to 1. As of now, you ignore that. What we are doing now, 2.0 into 0.4 plus 3.0 into 0.6. You will add it, you will get this. Same here, torch, same parameter dot torch tensor. Now two values dot. Now see, you are using dot product. When you have a single values, okay, you are just using x cross w. Now if both are tensors, okay, you are using dot. So it will use dot product. Background x dot w. Same thing here, three inputs. TensorFlow dot constant. See, dot constant. Whenever you go constant, you can just increase one more number. Okay, here also one number, constant, constant, constant. All are matrices. This is 3D. Scalar, constant. Vector, constant. Matrix, constant. Tensor, constant. And then dot product, see, tensor dot. You can use it to do the dot product. You can use anything. Okay, so same here. Okay, so any number you can increase constant, corresponding weights, you have to use dot. 1.5 into 0.2 plus 2.5 into 0.3 plus 3.5 into 0.5. Same thing here also. Okay, output is same. 2.44, 2.44998. Here you have to use dots. Okay, so this is how you can apply like various number of inputs. So to the same neuron. Now, bias also. What is bias? So bias helps us to shift the origin. Like suppose we are assuming that any curve uh, always pass through the origin, but sometimes for the flexibility of the model, we have to assume that it may move away from the origin, like from here. Okay. So how much you have to shift the curve from the origin is called as bias. So that's just the formula is that as someone pinged, weight transpose into X plus B, where B is the bias. Just you have to add bias. Now, if you go and see in our Pytorch case, this same, I have one constant, I have one weight for this weight, and then this is the bias. This is also variable. Bias also learnable parameter. Now see, you are doing dot product between X comma Y. That means the input into weight plus bias. In Torch, this is a tensor. These are the two parameters. Inside that, these are also tensors. And then you are using dot product between X comma W plus you are adding the bias. So same here, same thing here. X comma W plus B. X comma W plus B. The way you just transform, say dot product only. So everything syntax almost remains same. Some careful you have to take. Everything will remain same. Next, constant input, two inputs now. Whenever there are two inputs, you must have two weights, but bias will remain same. Okay, so it will be like this. So there will be a neuron. You can have any inputs. It may be one input. That input is connected to neuron. So this connection indicates they receive weight. So input into weight is what? Next, another input. Okay, another weight. So you may have 1 crore inputs. You have 1 crore weights. But bias will only be 1. Okay, so this is the bias value. So you have these two things. You have to multiply, then you have to add the bias. See, now tell me what is C? This is the input. Weight is attached to the input. Bias is also a parameter. Now, what is the input value of this bias attached? Like this X1, okay, something is there. What is the value? You got it? So you are multiplying input with the weight. In the formula, it is, what is the formula here? The formula is, okay, so input into weight plus bias. So input is multiplying with the weight. Similarly, input is multiplying with bias. But here you are adding bias. So what is the input? What is the input of the bias? What is the input of the bias? Scalar value. Scalar 0. Then if it is 0, yes, Abdul Mukit. If it is 0, then there is no bias because 0 into B. But when you're writing B, in majority of cases, we assume that it is 1. So here it is 1. 1 is there, and this bias you have to learn. Whereas these inputs you can depends upon the input. Okay, so that is how input. You see, same cases, you just keep on adding bias. This is Pytorch representation. This one same. 3 inputs, 3 weights, 1 bias, 0.5. Same, 2 inputs, 3 weights, bias. So the output will remain same. See, output also remains same. Okay, so that is how 2 neurons. Now see, 2 neurons now. 2 neurons. So when it comes to two neurons, that is also same thing. Okay, I think where it is same, two neurons also. Okay, 1 neuron, 2 neuron. So it all depends. See now, see here, X, 2 neurons. So I have 2 neurons in a layer. Okay, next. So whenever there are 2 neurons, input is 1. So I'm starting with 1 input, X1. So input is always connected to 1 neuron. This input is also connected to this neuron. Whenever there is a link, there is a weight. So this is a weight vector. So this is 0.5. This is 0.7. X1. X1 is the input. I just initialize it to 4. Now tell me what is output here and what is output here? So 4 into 0.5. Okay, here 4 into 0.5, and that means 2.0. Here 4 into 0.7. That means 0.28. That's it. So input into weight, input into weight. As of now, no bias. If bias is there, you have to add a bias also. Okay. See, why are we taking transpose? Okay. See, why are we taking transpose? Wait, suppose C. Input. Input is 1, 2, 3. Okay. Suppose weights. Wait, I have 3 inputs. Or okay, I have only one in 4. When you want to multiply, see, you have to multiply like this. Okay. Weight into this. Into this. Okay. Transpose. When it comes to more numbers, we will understand. I will explain that later. Okay. As of now, no issues. So this is done. Next, what is this case? This case also same thing. 2 weights. This one Pytorch. This is Tensorflow. Okay. So variable, same thing. Variable. It is constant. TF dot constant. TF dot constant. I think both are same. So 2.0, 2.8. Okay. Next, 2 neurons. Same thing. 2 neurons. Okay. See here. 1 weight. Okay. So connected like this. Neuron input into weight, input into weight. Just now we have seen. Okay. Next, 2 inputs. These are the 2 inputs. Okay. 2 neurons. 2 neurons. And I have 2 inputs. What are those? 2, 3. Same thing. This input is connected to this neuron. 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 So how many weights I have? How many weights I have? How many weights? 4 weights. What is the formula? Weights equal to what? How I can frame the formula? Can anyone frame the formula? Four. But how to frame the formula for this simple, for this kind of a network? How you can frame the how you can compute the weights? I need some formula. Very good, Kaushik. Very good. So I have some number of inputs. I need to multiply with the number of neurons. That's it. Very good, Arya. Okay, that's it. So now what I have to do? This neuron, same dot product. This neuron dot product. So here, suppose weights, assume that this is W11, this is W12, this is W21, this is W22. Same thing. See here, input 2 into 2 into 2 plus 3 into this. For neuron 1, these are the weights. Okay. Next, for this neuron, these are the weights. Same input. Input into this plus into this. So this is what we got. Okay. Next, 3 inputs. Same thing. I have 3 inputs. I have 3 inputs. Same 2 neurons. So this input is connected to these 2. This input is connected to these 2. This input is connected to these 2. Same thing. This, if I want to compute this neuron weight, this neuron output I want to compute, then what I need to do? I need to multiply the inputs. So I have the inputs. Then I have to do the dot product with the weights. So what are the inputs I have? 1, 2, 3. Then what are the weights for neuron 1? They given. What they given? They given as 0.1, 0.2, 0.3. Same thing, dot product, not matrix multiplication, dot product. Okay, 1 into 0.1 plus 2 into 0.2 plus 3 into 0.1. Same here. This input for the second neuron, this input into this neuron. And what is the output shape? What is the formula for output shape? Can anyone frame the, can anyone frame the, sir, I didn't understand this input. 1 second. Input into number of neuron. Okay, Pooja Soni. What my question is, the weights, the links, each link represents the weight, right? Each link represents the weight. So how many weights I have in this simple network? This is my input, and this is the number of neurons. In this case, what is the number of weights. So number of weights equal to number of inputs 2 into number of neurons 2, that is equal to 4, that is equal to 4. Okay, hope you understand. Now tell me, what is the formula for the number of outputs? So this is formula for the number of weights. Now what is the formula for the number of neurons? Number of outputs. What is the formula for the number of outputs? What is the formula for the number of outputs? What is the number of classes? Okay, number of outputs. Yes, Pujaswani is correct. And Shambhavi Sinha is also correct. Number of classes equal to number of neurons. Both are correct. Okay, but number of classes we didn't discuss. So I just given the neurons. So number of output, how many outputs I will get? One from each neuron. So number of output equal to number of neurons. So two outputs, one for one neuron. Okay, fine, that's it. So now two neurons. Okay, case, what will be the shape? So I'm multiplying 2, 1 into, see input, 1 input. So 1. My weights, 2 cross 1. Okay. So if you see here, if number of neurons is 2, output will always 2. 1 from this neuron, 1 from this neuron. So this we understood. Next, number of neurons is 2. This we understood. Now, one input. So one input, what we are doing, weights, see here, weights. I have how many weights? See this into this. So one input, this case, 2 neurons. So I'm multiplying. Okay. So how many weights I need? I need a vector of 2, 1. That means 2 rows, 1 column. So this is my weight vector. 2, 1. Okay. Okay. Next input. This is the input. So input may be one vector. So what I will do, this into this plus this into this, a single value. Next, if I increase the number of inputs to 2, if I got 2 inputs, then what will happen? Okay, 2 inputs. Okay, so 2 rows. When I have 2 inputs, then what happens? This this will also be like this. This will also be like this. Then my weight matrix will become like this. For this neuron, 2 values. Another neuron, 2 values. So 2 into 2. So 2 into 2 into this vector. 2, 1 vector. Clear? No need to reshape. It will work. It will work. That, okay, no need. Next, if you see here, inputs, 3 inputs. Okay, 3 inputs. Then what happens? 3 inputs means one more. Then again, like this, it will become like this. Okay, then matrices, weight matrix, 2 input. This represents the this one, 2, 3. What is 3? Inputs. Okay, so this is the input. This is the neuron. Okay, so my shape is 2, 3. Why? Because see here. Okay, so 2, 1. How I represents the weight? If this is the case, 2 rows, 1 column. Okay, next multiply 2, 2. 2, 2. Okay, next 2, 3 into this one. Here 3. Okay, so 3, 3 will nullify, 2, 2 nullify, 1, 1 nullify. You always get 2. That is the 2 output. Okay, clear? That's it. So this is how it will work. Same code also. Code, same thing. I will Okay, so same thing. You have to write here in the code also same. As you keep on increasing, just a dot per 2 inputs. Now bias also. If you want to add bias, see here. So if you want to add bias plus B, this will remain same. This will remain same plus B. Okay. So any input, irrespective of this is the input, this is the weight, this is bias. Bias is always a single value. See here, bias is always a single value. According to your inputs, your weights will change, but bias will remain same. The formula is dot product between the input and the weights plus bias. Okay. So fine. Next afternoon, what we will do in the afternoon class, what we are going to discuss is various scenario like multiple neurons. Okay, single layer, multiple layer. Okay, like this incrementally we will improve the network and how to write the code in the Pytorch and Tensorflow. And finally, how to do the forward pass, last computation, backward pass. All those things same like this we will thoroughly study. Okay, so any doubts? Hope you enjoyed. So afternoon, once lunch break is over, we will meet and then incrementally we will improve the network. Each case, how the network will vary. TensorFlow, Pytorch, what will be the output? All the cases we will study, and finally we will build one network, use it for classification. Okay, clear?
Thank you, sir, for your valuable time. And sir, I had a query. Students were asking whether they can get the slides and
Yes, yes,
notebook.
I will share. I will share, no issues.
Okay, sir. Thank you so much.
Okay, we'll meet in the afternoon and then we'll discuss further incrementally how we can use TensorFlow and Pytorch to build the network. Okay, thank
Okay.
you.
Thank you.